We're going to finish this chapter in section 3.3. We're going to talk about inequalities involving quadratic functions. So let's see how we're going to handle those. Now I should point out there are a couple of ways we can do this. One is the author's way. It takes a little longer, but it's doable. First is using the graph to determine where the function is positive, negative. And the other one is actually do an algebraic method of doing this. So I'll explain both ways how to do this. First of all, a quadratic inequalities will look like this. You have your f of x, which is in the form ax squared plus bx plus c. Remember, that's your quadratic expression, and of course, a cannot be 0. Now, with this, we could have something in the form f of x greater than 0 or f of x less than 0, and of course it could be greater than, equal, less than, or equal to. It could be any one of these configurations. Let's take a look at an example actually on how to do this. Suppose I have an expression x squared plus x greater than 12. Okay, notice that we can rewrite this. If I move 12 to the left, it's going to be x squared plus x minus 12 greater than 0, right? So I'm looking at this version of it. So that is a quadratic inequality, and one way to do it is to graph it. Now to graph this, I'm going to use the methods of the previous sections that we graphed them. I'm going to find the vertex. The vertex is going to be at negative b over 2a and f at negative b over 2a because I'm given the polynomial form of this function. The ABCs, what are the ABCs? A is 1, B is 1, and C negative 12, right? There you go. A, B, and C. Match it against the ABCs in the original form. Good. Now that I have that, I can determine the vertex. The H component of the vertex is going to be negative B divided by 2 times A, or simply negative 1/2. To find K, the Y component of the vertex, we usually do F at H, right? In this case, F at negative 1/2. So now what I need to do is I need to substitute negative 1/2 into my quadratic function. That's going to be negative 1/2 quantity squared plus negative 1/2 minus 12. Negative 1/2 squared is 1/4 minus 1/2 minus 12. And this is going to be negative 12 and 1/4. Okay, so we have that. Now, those will give me the coordinates of the vertex, and we have those. Let me write them. Negative 1/2 and negative 12 and 1/4. Cool. Now, what we need to do next is we can actually graph this using our Cartesian coordinate system. And let me bring my coordinate system. And there is my coordinate system. Like magic, it just appears, right? Okay, let's label these. And now suppose this is negative 1/2, where negative 1/2 is on the x-axis. And suppose this is negative 12 1/4 is just a hair on there, right in here. There you go. Now, by the way, my x, y tick marks are not the same, and that's perfectly fine. We can do that. So here's my negative 1/2. And this is, this will be negative 12 and 1/4. Just above that is negative 12. Now, because A is positive, right? A is positive. A is 1. A is positive, so the parabola is going to open upwards. So far I know it's going to go up from the vertex. Remember, that's the low point, the vertex. And again, because I'm so close to the y-axis, I want to graph it accurately. Let's find the y-intercept. Where is it going to cross the y-axis? For the y-intercept, you plug in 0 in the function. F at 0, which will be 0 squared plus 0 minus 12, and that's negative 12, and it's just above this point. So there you have it. That's going to be the right side of this. And the left side, of course, will be a mirror image, right? And there we have that one. Okay. Now, it's kind of like the exercise we did earlier in my previous lecture for section on quadratic functions. I can't remember which exactly was it. It was graphs of quadratic functions. The previous lecture to this one. All right, so now in order to do it using graphing, I need to find these x-intercepts. So to find the x-intercepts for any function, we set the function equal to 0 and solve for x's. The function x squared plus x minus 12, set it equal to 0. So this now I can factor it. This is factorable, x plus 4, x minus 3. And each factor, we set it equal to 0 by zero factor theorem. And x minus 3, 0. And that's the premise of that is if two things multiply to 0, at least one of them must be 0. And that's what allows us to set each of those equal to 0. And there we have it. So one solution right in here, that's when x is 3, the positive side. And on the negative side, you have negative 4. Okay, and if you notice, the distance from negative 1/2 to 3 is exactly the same as negative 1/2 to negative 4, namely 3.5 units on either direction. Okay, perfect. Remember, we wanted to solve this inequality, so don't worry about about other things that we may have done in the previous sections. Now, here's the key part, which actually ultimately now helps us solve this. And again, I should point out, this is the long way. This is the hard way of doing this exercise or example. And I'm doing it the way the author in your book does it, in case you read the book and you want to do it his way. But I have a better way of doing this much faster. But let's go through the motions. Now, the fact that I have greater than 0, this is the important step. Greater than 0 means positive, correct? Positive. A number greater than 0 is positive. Now, we're looking at the function, though. We're looking at the whole, this is the function now, function greater than 0. So, we're going to look at places where the function sits above the x-axis. See the value of the function in the green. Here f is positive, and so is here, f is positive. And between the x-intercept, notice the function lies below the x-axis. So it is indeed negative, right? That f is less than 0. Whereas the other ones, again, f is greater than 0 here and greater than 0 here. Now, we are seeking positive values of the function, correct? So the solution, therefore, is to this exercise. Positive values from negative infinity on the x-axis up to negative 4, parentheses. Function is positive, and is positive from 3 to infinity. All said and done. This is what we were seeking going through all of this. Okay, now again, this is a way of doing it, but let me show you a much easier and faster way of doing this. We have the solution, and let me start with the original example that we did. The original example was x squared plus x greater than 12, right? And it's up here, this one. So let's solve this now using an alternate method. The alternate method calls for this. Two things must be in place for this method to work. One, we have to have this number on that side must be 0. Okay. So that's the first and foremost of the two things. This is the priority. So in order to remedy that right away, I'm going to subtract 12 from both sides. There you go. Now it is 0. That's number one. Number two, the function must be in factored form. That's the function. must be in factored form, and the factored form of this is going to be x plus 4 times x minus 3. So we have both of those in place. 0 on the right, factored form on the left. Now once we have that format, we're going to look and see what makes each of these factors 0. X plus 4. So negative 4 makes that 0. X minus 3. 3 makes that 0. Then we're going to draw a number line here. Okay, so here's my number line. This is 0. 3 is a number to the right. Negative 4 would be a number on the left side. Okay, so I just divided up the number line using these numbers. Now once we've found these numbers, next I need to choose a test point. Okay, a test point. The test point is any point of your choice for the test value. The horizontal number line represents f of x. And these are actually, I know it's the x values, but we're looking at the sign of f of x. That's what we're looking at on the horizontal axis. Now, I'm going to choose 0. Let x be 0. And you want to pick easy points. 0 is usually easy. The only thing about test point, it cannot be negative 4, cannot be 3. Because if you get those, it's not going to help us decide on the signs of the function. Now, because I have greater than, by the way, and something, yeah, because this is greater than, so at negative 4, I'm going to have open circle and open circle at 3. Right? And those open circles translated into these parentheses right here. You see that? Now my test point is 0. I'm going to plug in a 0 now into this function. So I'm going to get 0 squared plus 0 minus 12. And 0 squared plus 0 minus 12 is negative 12, right? Now we don't care about the magnitude of that number as much as we care about the sign on the number. Negative, right? So I'm going to put negative, 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 negative here. What is the significance of all those negatives? What that means is that regardless of what test point we choose, anybody's test point, we're all going to get a negative value of the function. So for instance, let's say somebody else says, I want to choose x to be 1, a number here. Well, they would plug in their numbers, right? 1 squared plus 1 minus 12. That's going to be 2 minus 12, negative 10. See that? The fact that it's negative is what matters. The magnitude will be different, but it's a negative number. So we can try any number between negative 4 and 3. You're going to get a negative value for the function. Now, let's try a different test point. This other test point, I'm going to choose something outside of 3. Let's say 5. I'm going to plug it in. So I'm going to get 5 squared plus 5 minus 12. That's going to be 30 minus 12 or positive 18. Again, the sign is what we care about. So I'm going to put plus 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 here. So that means anybody's pick beyond 3, we all should get a positive value for the function. And you can finally try a number less than negative 4, like negative 5 for your test point. Plug it in and you will see that the value will be positive once you plug it into this function. And there we have it. Now once we have partitioned this number line into positive negative segments, we're going to take a look at the sign on the inequality. And that's why this has to be 0 because of what we're about to do now. Greater than 0 means positive, correct? Positive. So positive segments here and here on the number line. And from that we can actually now write the solution. So the solution, and if I kind of throw in infinities on both ends of the number line here, then I'm looking at the interval notation using the graph. this segment of the number line as part of the solution is all positive, means the function will take on positive values there. So the solution, again, just like before, from negative infinity up to -4 is positive union the right segment on the number line, stretching from 3 to infinity. There you have it. And we have solved this inequality. See how that works? So that's, to me, that's a better way of doing this. And we'll do another example in a moment where we use this algebraic method as opposed to graphing it. And now that I've explained it in this way, the next example you will see is going to go a lot faster. So in this example, let's say I want to do 6 times x squared minus 1 greater than 5x. Now let me make that greater than or equal to, just so you have seen the part. It could be greater or equal. So let's try that. Again, in the book, most of them are greater than or less than. So maybe I won't do that. The only difference would be if you have equal to, these parentheses will turn into brackets. That's it. It's the only difference. So let me stay with greater than in this one. So first thing I need to do is distribute. Bring 5x over. 6 times -1 is -6, greater than 0. Remember, we have to have 0 on the right side, and we do. Then we're going to factor this. The factored form of this expression is going to be 3x plus 2. You can verify this. And 2x minus 3. Okay, that's factoring. If you need more practice on factoring, then you can kind of do a Google search on YouTube, or just a search on YouTube for factoring, and you're gonna get some hits, and you can review your factoring skills there. So there you go. That's factored form of the quadratic. Now remember, next step we're gonna see what makes each factor 0. What number makes each factor 0? -2/3 makes this one 0. 3/2 makes this one 0. Good. And next I'm going to draw my number line. Again, this is the sign of the function we're looking at. So we're looking at the sign of f of x over that number line. This is the center of the number line. -2/3, let's say that's -2/3, and 3/2 is here. Okay, because I have greater than, so these points we put open circle, because at those points we get exactly 0. We want it to be greater than 0, not equal to 0. Good, and then you pick your test point. So I'm going to let my test point be x0 and plug it into this function. So I'm going to get 6 times 0 squared, -5 times 0 minus 6. That's going to be -6, right? Negative is what matters. Minus, 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 minus. Now you can try these other two segments here and in here. And when you try it, you're going to see that these are going to alternate to a plus and a plus here. Okay. Therefore, again, for the test point here, for example, let it be 2. Down here, let it be -1. And you can see that you get those positive signs for the function. And what are we looking at here? Well, greater than 0 means positive, correct? Positive values. And positives occur on the lower and the upper segments of the number line. And there you go. We are done. -infinity to -2/3 parentheses union 3/2 to infinity. And that will be the solution to this one. All right. So I recommend doing it this way. It's a lot easier than going through and graphing these quadratic functions. But again, at least you have 2 ways of doing it. Do it however you feel like it. I highly recommend this way of doing it as you go forward with in future chapters and sections. All right, and with that, we are done with this lecture, and we are done, in fact, with this whole chapter. Again, thank you for watching, and see you in another video. Not see you, but you know what I mean. Take care.